Good morning. Today I am going to explain about eccentric connection. So in the eccentric connection, there will be different types of joints will be there. So you can see how the joints are divided, like depending upon the arrangement of bolts and plates, and depending upon the load transmission, and depending upon the nature and the location of load. And one more thing, there will be a different type of bolt joints will be there. So in the first one is lap joint. You can see in the top lap joint, butt joint. So lap joint is divided into single line bolting, chain bolting. So you can see here all the lines will be in the chain manner. So here the next video you can see next diagram, like how the zigzag bolting will be there and chain bolting will be there. So these are the different types of figures to show about the bolt joints, like line bolting, chain bolting, everything. So when it is coming to single bolted lap joint, here will be a one bolt is there. When it is coming to triple bolt lap joint, so here triple bolts are there. And it is coming to double bolted single butt cover joint, so this is known as butt. So double butt, you can see another one material connecting with the butt and one bolt. So this is the one. So here this is the bolting pattern. So already we discussed line pattern, and this one is diamond pattern. Due to it is diamond in manner, and this one is zigzag manner. So you can see here single line bolting. So this one is single line bolting, and you can see this one is double line bolting. This is the top view, and these are the different types of bolt front views and sections. So you can see here what is by direct shear connections and eccentric connection, and pure moment connection and moment shear connections. So direct shear connection, directly it is applying the load. When it is coming to eccentricity connection, some eccentricity E will be there. And pure moment connection, you can see here both side load is applied. This is pure moment connection. And moment shear connection means this is the one moment shear. You will, due to that you will get EM P into E, that is the moment shear connections. So while you are going to designing the bolter connection, so these are the things you have to remember. So first point is the length of joint should be same as possible to save the material and cover plates and gusset plates. And when the number of bolts should be increased gradually towards the joint for uniform stress distribution in bolts. And before going to do the design, you have to do the arrangements to satisfy the pitch, cards and hinge distance requirements. When the strength of the joint reduces due to the bolt holes, the reduction in area due to the bolt holes can be minimized by arranging in the zigzag form. So this is the thing to design before going to design the ordinary bolt or high friction bolt. So these are a design you have to do procedure: shear strength of bolt, bearing strength of bolt, design strength of bolt, plate, combined shear and tension. Already I said here one plate will be there, another plate will be there, one butt joint I am keeping, so I am giving the bolt. So in this what I am saying, not only bolt you have to check about the plate also. That's what they given here: shear strength of bolt, bearing strength of bolt, tensile strength of bolt and tensile strength of plate, and combined shear and tension. So anyway, in the class when I am discussing one problem, you will understand about more clear cut idea. So you can see here how to check one design example I given, how to find out the bolts in shear. So you can see in the top, so this is the formula VNSP. VNSP is nothing but the nominal shear capacity of the bolt. So FUB divided by root 3 into NN into ANB plus NS into ASB, beta LJ, beta LG and beta PKG. So all the things I explained in very clear manner. So final thing is you have to find out what is VDSP. VDSP is nothing but design shear force, to find out the design strength of the bolt. So to find out the design strength of bolt, you have to find out the VNSP divided by gamma MB. Gamma MB is nothing but the partial safety factor for the material of bolt. So it will be depend upon in the field you are doing the weld, or in the site you are doing the weld, or in the shop you are doing the weld, it will get differ. You can see what are the number of shear planes, what is by shear planes without thread, and reduction factor, and net tensile area, so all the things. So this is not our bolt in shear. So if I take one example and if I discuss, you will understand more in detail manner about shear strength of bolt, bearing strength of bolt, tension strength of bolt and tensile strength of plate, and finally combined shear and tension. So hope you understood the concept. So if you have any doubt, you can please ask me in the normal delivery session of the class. Thank you for listening.